In today's video, we are going to talk about the characteristics of materials which every civil engineer should know. But before discussing about these characteristics, let us first take a look at the tests associated with the materials of construction, starting with the tensile test. The tensile test is a fundamental mechanical test performed on steel to determine its mechanical properties. The basic idea of the tensile test is to place a sample of a material, the specimen, between two fixtures called grips, which clamp the material. The specimen's dimensions like length and cross-sectional area are always known. A tensional load is applied at the ends of the specimen and the corresponding change in length measured. We keep on increasing the load, while at the same time measuring the change in length of the specimen until it snaps. Having obtained the results, a stress-strain graph is plotted from which several characteristics can be determined, including sigma E, the elastic limit, also known as the yield strength; epsilon E, the elastic deformation; sigma U, ultimate strength; epsilon U, ultimate deformation; and of course the Young modulus, which is the gradient of the linear portion of the graph. Let us now look at the compression test. Compression test is done on concrete, where cubic and cylindrical specimens of known dimensions are subjected to increasing compressional stresses until they crack. The obtained results are used to trace the stress-strain graph. The most important characteristic obtained here is the FC28, which is the characteristic value of the cylindrical specimens. It indicates the strength of concrete after it has been allowed to cure for 28 days. Having looked at the tests associated with some of the materials of construction, let's now discuss about the characteristics, starting with elasticity. Elasticity refers to the ability of a material to return to its original shape after being stretched or compressed. Graphically, it's represented by the linear portion of the stress-strain graph. Elasticity is very important in civil engineering. It helps engineers in material selection, structural analysis, and predicting the performance of building materials. For example, a bridge is able to carry loads of vehicles passing over it thanks to this characteristic. As the vehicle passes over it, the bridge deforms and surges downwards. These deformations are always very small thanks to the stiffness of the materials used to construct these structures. Once the vehicle crosses over, the bridge regains its initial shape as long as the elastic limit is not reached. It is important to note that depassing the elastic limit can lead to some catastrophic consequences. That's why it's important to use plastic materials in structures, hence plasticity. Plasticity refers to the ability of materials to continue undergoing deformations without breaking even after reaching the elastic limit. These deformations are permanent, meaning that a material won't regain its initial shape once it undergoes plastic deformation. Graphically, it's represented by the nonlinear portion of the stress-strain graph. Let's now look at resilience. Resilience refers to the ability of a material to absorb energy and recover from deformation when subjected to stress or impact. It reflects how well a material can withstand forces without failing or undergoing permanent changes. Graphically, it is the total area under the elastic portion and the plastic portion. It is the maximum energy that can be absorbed. Resilient structures can withstand and recover from adverse events, such as natural disasters, impacts, or other unexpected loads without failing. Reinforced concrete is an example of a resilient material. Another important characteristic is stiffness. Stiffness refers to the ability of a material or structure to resist deformation under applied loads. It's a measure of how much a material will deflect or deform when a force is applied. Stiffness is an important property in the design and analysis of structures as it influences their stability, strength, and overall performance. Stiffness can be quantified in different ways, depending on the context. 1. Material stiffness, often expressed through the Young's modulus. 2. Structural stiffness. For structural elements, like beams or columns, stiffness can be described in terms of their geometry and material properties. The formula for stiffness K can be represented as K equals F delta, where F is the applied force and delta is the resulting displacement. 3. Flexural stiffness. In beams, flexural stiffness is important and can be expressed as EI, where E is the Young's modulus and I is the moment of inertia of the beam's cross-section. Higher stiffness generally means less deflection and better load-bearing capacity. Let's now look at hardness. Hardness refers to the resistance of a material to deformation, scratching, or indentation. It's an important property when assessing the suitability. For example, the hardness of concrete is often evaluated through its compressive strength, which indirectly reflects its ability to withstand wear and tear. Brittleness. Brittleness in engineering refers to the tendency of a material to fracture or break without significant deformation when subjected to stress. Unlike ductile materials, brittle materials exhibit little to no plasticity. Common example of a brittle material is concrete. This is one of the reasons that it has to be reinforced with steel bars to come up with reinforced concrete, which is a ductile material. And finally, let's discuss about creep. Creeping concrete refers to the gradual, time-dependent deformation that occurs when concrete is subjected to sustained loads over a long period. This phenomenon is particularly significant in structures that experience constant stresses, such as beams, columns, and pavements. Factors influencing creep include 1. Time. The longer the load is applied, the more noticeable the creep will be. 2. Temperature and humidity. Higher temperatures and humidity levels accelerate creep. 3. Concrete composition. 4. Stress level, with higher stress levels leading to greater creep. And that bit brings us to the end of today's discussion. Please feel free to use the comment section below and make sure to hit the subscribe button for more. See you on the next one. Peace.